general relativity, step by step. Now last time I was looking at differentiation, covariant differentiation of a arbitrary tensor. Well, I've got a third order tensor here, but you can see the pattern. And now I'm going to spend a little bit of time fooling around with you can see how important it is. I'm going to spend a little bit of time fooling around with the Christoffel symbol ijk. And in particular what I'm going to do is work out how to contract it. So that equals sum over I, Christoffel symbol ik, and we'll see how useful this is later on, but for the moment I just want to contract it. Well, let's write out the definition of the thing and then we'll see what happens. jk equals a half g. That index I is this index I here. It's contracted on m, and then we've got the differentials. G dot dot by di x something plus G dot dot by di x something. I'll fill the somethings in a minute. Minus D dot dot x something. Now what do we do? 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 That m contracts on the first index of G, and then the second index, and then the downstairs. That J is going to be there, and the K is going to be there. Here the K is there, and the J is there. Here the K and the J are on the both on the same side. Right. Well, that's great. It's a pain in the neck to evaluate. I've been sort of fooling around with this and thinking about different types of metric tensors to show for examples for the course. And I, frankly, got myself tangled in knots. It's a pain. And if we're going to be considering this ik contracted on the first index downstairs, well, let's write it out. It's a half g im di g m I, because j equals I, over di x, k is free, isn't it? Plus di g k m by di x I minus di g k I by di x m. This is now summed over I and m. So what does that mean? Well, if you look at this, because it's summed over I and m, you can see that these two terms are equal. Well, they're not separately equal, but when you sum them, because all I've done is exchange the k and the I, and because the g is symmetric, these terms just cancel. So now I'm left with this beautiful thing of the Christoffel symbol is of ik. Well, I'll use this later. For the moment I'm just playing with it. Half g im di g mi by di xk. Okay, well there it is. Equals what? This is a complicated, difficult thing, even for two dimensions, even for flat surfaces. Remember the h theta coordinates where h equals x and theta equals tan y over x. Even for that, calculating this beast is a bit of a pain. So I'm just going to leave that there, and I'll give you a nice way of evaluating it in the next screencast. I'm going to stop there.